All right, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com broadcast. I'm Charlene O'Hanlon, Managing Editor at MediaOps and the moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which has a demo, and I'm always excited about the demos. Love the demos. Our speaker today, well, the webinar is called Introduction to Chaos Engineering, Finding Failures Before They Become Outages. And our speaker today is Jacob, is it Plick or Pleek?
Plick.
Plick, all right, Solutions Architect at Gremlin. Jacob, thank you so much for joining me today. I'm so excited about this webinar.
Yeah, me too. Thank you so much. Thanks for having me. It's really exciting.
All right, well, I know you got a great webinar on tap, great presentation. So I'm going to take myself off camera, put myself on mute, let you get right to it.
All right, thanks, appreciate it. And hello, everybody. My name is Jacob Plick, Senior Solutions Architect here at Gremlin. So I help a lot of different companies across a variety of industries, including finance, e-commerce, airlines, retail, insurance, you name it, build out their chaos engineering practice. So in case you're not familiar, Gremlin is a hosted SaaS platform that lets you run chaos engineering experiments simply, safely, and securely. So I've actually been at Gremlin for a little over 2 years and previously worked at a large sports e-commerce company called Fanatics, where I served as both a cloud operations and senior site reliability engineer for, I believe, just under 4.5 years. And there I was responsible for providing a reliable e-commerce experience that processed upwards of 1,100 orders a minute, all while training a bunch of junior SREs. So reliability has been my bread and butter for a long time, especially on peak days such as Cyber Monday and Black Friday. So really excited to chat with all of you today. So let's get right into it. So chaos engineering is a term that is becoming very popularized. So many of you may know what it is already. Many of you actually probably know about it due to an open source tool called Chaos Monkey that was open sourced by Netflix. But sometimes it's actually better to define something, at least to start with, by defining what it isn't. So chaos engineering isn't Chaos Monkey. The ultimate goal was just, and it was a good end goal, but the approach actually had a few pitfalls. So what Chaos Monkey would do is allow you to randomly terminate hosts instead of targeting particular instances, which isn't great from a targeting mechanism piece. It also started with an entire environment instead of selecting and starting with a few hosts and then growing the blast radius, which we'll talk about in a bit. And the tool is actually forced to run on all teams, often with little to no communication. But something that is interesting is that the tool was run automatically and continuously to allow or ensure that there's no backward drift into failure. So if you remember nothing else, remember these 4 builded words: thoughtful and planned. The term chaos is actually more of a misnomer. It's more about trying to validate or disprove a hypothesis. And revealing weakness. The ultimate goal of chaos engineering is actually to shine a light on latent issues that already exist. So I like to tell the story of if you go up to an attic and you shine a flashlight and you see a bunch of spiders, and in some cases, I know folks have basements. I live in Florida. Couldn't tell you what a basement is. But if you see a bunch of spiders and then you just turn off your flashlight, the spiders are still there, right? It's not exactly an easy thing to ignore once you've shined a light on it. So really this is about simulating the chaos of the outside world in a more controlled environment. So we're actually introducing chaos, but it doesn't mean we're doing it chaotically. So as with any experiment, you want to start with the smallest increment that will yield a signal, but also you want to over communicate, especially if you're an SRE team advocating for this practice with your other teams, app teams, development teams, for example. And also, it's actually really a practice that needs to be iterated on, continually improved, and even automated. So even though it's getting popularized now, it's actually something that's really interesting is that this is something we've been doing as an industry for a really, really long time. So, in the mid, to early 2000s, there's a gentleman by the name of Jesse Robbins who worked at Amazon. He became coined this master of disaster. He's actually the person that coined and popularized the term game day. He'd actually run into an Amazon data center, unplug a power network cable, and pull up his phone and wait and see who responded. So that's a pretty crazy way to get started. Then leading into the early to mid 2010s, many large enterprises are actually practicing proactive disaster recovery testing behind closed doors. It's more of their secret sauce. And actually, Netflix, when they actually created Chaos Monkey at this point to facilitate Netflix moving from data centers or on-prem data centers, I should say, to the cloud. Then in 2011, Netflix announced the Simeon Army toolset, adding a few additional failure modes. And then in 2014, Bruce Wong coined the term chaos engineer while working at Netflix, and that is when the industry started to really join Netflix in practice chaos engineering as a means of increasing resiliency in complex systems. And then 2016 is actually when Gremlin was founded by our co-founders Colton Andrus and Matthew Fornicari to help democratize this practice and help companies harden and prepare services for internet scale. So why should we be doing it though? So complexity is only on the rise, and as things get more complex, there are a combination of ways, more ways to fail, and failure is a direct correlation to lost revenue. Now, we're not saying that we could root out every single failure mode, but we can begin to and start to eliminate entire classes. There's a lot of low-hanging fruit out there that teams run into, whether that's disk exhaustion or timeout tuning as a small example. And then from a DevOps perspective, Gartner, who's the world's leading research and advisory company, believes that the only way to successfully operate distributed systems is by doing chaos engineering. So Gartner actually draws this direct connection between chaos engineering and uptime. So leading companies like Amazon, Google, and Netflix already apply chaos engineering as part of their traditional delivery routine, and many more will follow this practice. But also, we have these dependencies on networks that we don't own, infrastructure that we don't control, orchestrators that are black boxes, legacy dependencies that unknowns, and frankly, people who could be unreliable. Testing just the code of an application will never uncover all of the errors. So even in Amazon, human error took out the S3 US East 1 region back in 2017. So we need a new way to test the other parts of the application stack so that we can be sure that we've configured everything correctly and that all the processes are in place. So there's a shift in architecture that's happening from monolithic applications to microservices. So what this means is we have larger, more distributed systems, which equals complexity. So these systems are built upon hundreds, if not thousands of microservices. And these, what we kind of jokingly call microservices Death Stars, such if you're a Star Wars fan, are a trace of the Amazon and Netflix microservice architectures. And the insane thing is these were pictures from 5 or 6 years ago. So imagine what this looks like now. Prime Day was just last week. Stranger Things, season 1 and season 2. What has to happen behind the scenes to make those companies ready for these types of things? But also, there's a shift in hosting from on-prem to the cloud as well. So this actually means that engineers have less control over their infrastructure. So we need to start architecting for failure early because we're no longer managing our own hardware. So this is why we need a new approach to testing failures of these large Death Stars of interconnectivity here. Also, I think in my younger grade school years, I took fire drills for granted. I'm pretty confident I'm not alone there. But something that's really cool is now we can actually train for incidents by doing these fire drills. So we do fire drills to train ourselves to stay calm and know exactly what to do when something's going wrong. So if you think back, especially if you're going on call, have you been given an all-call phone or pager and essentially been told, yep, the run books are somewhere over there, probably collecting some cobwebs. I don't even know when I logged into that Confluence stock and updated it, but good luck. And here's the truth is, in a lot of cases, you're responsible for the reliability and incident management on systems that you don't know anything about. So we can actually make on-call less painful by running these fire drill scenarios as part of onboarding a new engineer, as well as ongoing training exercises. But also something that's really interesting is we actually find that not a lot of companies are measuring the cost of downtime. So we actually created this model. So there's a reason for your application or your service. It's providing value to your end customer. And for that reason, that service needs to be available. So it's relatively easy to measure the obvious costs like revenue loss, but there's also a lot of hidden costs to downtime. So the formula we came up with was revenue loss and employee productivity, and then actually adding in customer refunds or SLA breaches, but also the unquantifiable metrics like damage to your brand and employee attrition due to burnout. So Amazon's actually estimated to lose somewhere over $200,000 per minute of downtime, which is pretty wild. But something that's really interesting is you want to start to think about the KPIs that you have for your business. So at Fanatics, we had something called an hourly flash report, and you would always know when it hit. It was director, VP on all the way up, and it was every 6 minutes of every hour. And the report was pretty simple. It's here's what we are forecasted to make, and here's what we did. So you have to imagine if there was any sort of variance, you know, everyone's running around trying to figure out what's going on. So something to think about. So when should we be doing chaos engineering? So as systems become increasingly complex, it becomes way more important to test for failures earlier and often. Now, I've actually heard, as you can probably imagine, a lot of different reasons why folks or companies feel like they're not ready to do this. So we don't have time. So respectfully, what is more important than making sure that your business is up and available? So in that case, odds are your day-to-day operations are a bit of a time suck because you're reactively firefighting. Things break on their own, one of my favorites. So fair, but sure, when things break at 3 o'clock in the morning, waking up engineers who then have to groggily dig through logs isn't an awesome experience. So wouldn't we rather break things on our own time at, say, 3 o'clock in the afternoon when everyone's caffeinated and our entire team's engaged? And we don't know how to start. So let's start simple. Is your service resilient to CPU pressure? Perhaps is resilient to memory pressure? Can you validate that? Great place to start. Just in zooming out, what are some just assumptions about how your system works? That's a great place to validate too. So part of this issue behind this mentality is the typical definition of operational maturity. So the majority of the industry, and I think this is about to change, considers being operationally mature as simply being ready to fight incidents. Now, this is a major component in the maturity of a company, but it's only half the picture. I actually like the way that Tim PagerDuty touches on this, which is the idea behind operational maturity is the ability for you to be proactive. So we can interpret this as architecting for failure in your development environments and then testing your assumptions early and often. So there's actually a relatively low bar to entry in defining when a company is ready to do this. So when Gremlin was kicked off, we came up with 3 qualifying questions here on the left side. So if any of these are no, then we're fighting an uphill battle. So let's start there. And then we can bring chaos engineering in as part of that process. And then on the right side, without some basic observability pieces, we're flying blind, and that's not great either. Plus, we can't actually, evaluate the outcome of our experiments. So let's start there. But if all of these are yes, then it's time for us to get rolling. There's also a level of maturity within chaos engineering for every step of this as well. So for example, we can start small at infrastructure failures. Let's test out and make sure that we're resilient to resource exhaustion, CPU, disk, IO, and memory. then we start talking about changing the state, whether that's killing processes, shutting down hosts or containers. Daylight savings time can cause some interesting clock skew, certificates expiring. It's a really great place to get started. So then once our house is in order and we feel like we've built a really sturdy foundation, let's test out our dependencies. Let's black hole or slow down that external API or that database and understand how our service operates when under that type of action. But of course, there's also DNS and packet loss that we can do at that level. Then at the application failure piece, we can actually move up the stack now and test at the request level. What happens when when I get a 500? How does that impact me? Retry storms. Things can get really interesting there. And then continuous chaos. Do we have confidence that we are resilient to a particular failure mode? Great. So then let's automate that and prevent that drift back into failure. So where should we be doing this then? So the ultimate goal is to test in all of production. You want to actually test in all stages of your development as well, so that way you can catch failures before they can affect your customers. Now, no two environments are the same. So essentially, to dive into that, what I mean to say is your staging environment is not production, no matter how close or similar that you try to get it. James Hamilton states that unless you're testing in production, there's no guarantee your recovery safeguards will function. So testing in production sounds scary to a lot of people, but that's where your customers live. I have a great example of this. A customer that I talked to recently, we were talking about their redundancy plans, and they have this active passive database cluster, and I asked, when was the last time that you tested it? And the answer was crickets. And so I was like, okay, great. That's where we're going to get started, because you want to make sure that that redundancy piece is there when you need it. So we talked a little earlier about the blast radius. So we always recommend starting small, carefully and purposely increasing your blast radius. So this means experimenting with a single or a few hosts at first, not your entire fleet. This also can mean starting in your development environments and then expanding outward. So there's actually a cycle of expanding your blast radius, which starts over as you escalate up your environments. So as you adopt the practice in your development phase, so your engineers are architecting for failure, then once you're confident with a particular failure, you can then begin testing that in staging on a subset of hosts, and then expand from there, and then just rinse and repeat on your way to production. But there's also, now that you have a carefully defined blast radius, you can actually take your experiments, starting with a small experiment magnitude, and progressively scale up from there. So that's a small amount of CPU latency or memory contention, and then increase as you build confidence in how your system will respond. So a good example of this is, let's start with a small amount of latency, 200 milliseconds of latency, and then work our way up to what we believe to be our timeout logic, for example. So who should be doing this? So to put it simply, the internet is unreliable. So if we blindly trust it to always work for us, eventually I'm sure will disappoint us. So if we zoom into our very recent developments, this recent move to everyone working from home and shopping purely online has put strain on companies in every industry. Many were not prepared for this level of demand. A lot of companies are switching gears, changing things to more curbside pickup, takeaway, things like that that they weren't prepared for initially. But the truth is if we zoom out a bit, this is a problem that we've been talking about for a long time as an industry. This crazy, rapid innovation digital world. We see things on Twitter of companies running into issues, and everyone's kind of there's a hashtag hugops around that. But whether that's regular e-commerce failures on Black Friday, whether that's, whoops, that's awesome. Time to wake up. Breakdowns at banks and financial institutions, and in the worst cases, life-threatening incidents on airlines. The cost of these major technological breakdowns goes far beyond just the billions lost in company revenue. But what successful, innovative companies have realized is that to move towards optimal reliability and to give control back to their engineers, we need to create a culture of proactively testing for failure constantly. So companies who rely on these customer-facing web apps to generate revenue and customer satisfaction, whether that's Netflix or Amazon to many other globally recognized brands in e-commerce, financial services, media, streaming, gaming, you name it, they're all embracing this concept. And they're doing it not to inject chaos into their environment, but to actually remove the likelihood of that happening entirely. So by injecting failure into our systems, that lets us see how they'll react and the side effects of those, so that way we're prepared for if something happens like a large disaster, so that their best day, the launch of a new product, Black Friday, or this new streaming series will actually be their best day and not their worst. The result, higher customer and employee satisfaction and increased focus on innovation instead of fighting fires. So no matter what the business, all of them rely upon the customer and that the customer has a good experience. As some of these names you might recognize. All of them have found value in proactively testing for failure. So how should exactly we should be doing this then? So this is where Gremlin comes in. So we have this platform that allows companies to do this proactively. So let's talk through a few use cases. So a great place to get started is verifying your monitoring and observability tools. This is a common place for folks to get started. So just validate what you've built those dashboards to do, and then how does that lead into what both the behavior of your actual systems as well as what your monitoring tells you to do. So personal favorite out of this particular list probably is slow response from a database, as for the most part everyone's relying on one of those, as well as something a little simpler around CPU spikes on your service, just to simulate runaway processes and understand what happens when that happens for you. Then we kind of zoom into specifically dependencies. So especially with distributed systems and external dependencies, we need to ensure that our systems will fail gracefully. And many companies run into trouble where a third-party dependency of theirs that they don't own is a problem and they don't have any fallback. So if we lose a non-critical service, like say a review service or a recommendation service, that shouldn't bring down our entire website. But similarly, losing connection to our DNS provider should fail over to another. So using chaos engineering, we can ensure that these controls are in place and that the impact of dependency loss is minimized. And I talked a little bit about this when we talked about fire drills, but incident response is probably my favorite place to start. So a common place that I'll talk to companies about is their previous pain points. What a previous incident that you ran into. Let's recreate that as part of your incident post-mortem exercises. Are we better than we were the previous time that this ran into a problem? And then this becomes a way for us to measure our mean time to detect and recover. And especially with the fact that, especially in the cloud where we have availability zones and regions, and different regions, this is a great best practice to start with. If we lose connection to an availability zone or a data center, how do we handle that? And then lastly, I joked about cobwebs and runbooks. So let's run through the playbooks that we create and validate that they're up to date based off of all the changes that we made about our systems. So with that, I'll get into a little bit of a demo and show you a little bit about what Gremlin looks like and a good experiment in which to run. So we actually have Gremlin running on this Kubernetes cluster. There's actually a microservice demo environment called the Hipster Shop or Hipster Boutique. Google open sourced it, so you can actually find that on GitHub if you'd like. And the actual Gremlin agent is installed there, running as a daemon set. And so we talked a little earlier about critical parts of our application. So what happens when the payment service is unavailable? We want to understand what that looks like from an error perspective, but also this shouldn't, even though this stops my customers from paying me, for example, this shouldn't bring down my entire website. Especially if I'm investing in decoupled microservices, I want to be able to validate this. So let's see what that looks like. Demo time. So let me switch gears here. Okay, awesome. So this is actually what the Gremlin dashboard looks like, but let me show you around the online boutique store that I'm talking about. So this is the front end, all of my products here. I can actually select one and add something to cart. There's even, based off of what I select, a recommendation service that will surface some other products, and I'll add that to cart as well. And I have the ability to place an order. So things are running pretty well. So what I'd like to do is actually come over to Gremlin and validate that once the payment service is unavailable, validate that actual behavior, and also making sure that doesn't affect anything else up the stack from a dependency piece. So I'll show you what that looks like. So this is actually a scenario that I've put together in advance, and it gives me the ability to black hole that dependency. So I already have my payment service container selected right here. And we talked a little bit earlier about the different attacks, but I've already selected the black hole of this dependency. And something that's interesting, we talked a little earlier about external APIs. So if the payment service is relying on something else, I had the ability to granulate this even further and actually say from the payment service to say PayPal's API, I could plug that information in, and then the port that's listening on and black hole that specific piece. But since I'm just black holing the payment service from being, or black holing the payment service from being available to the dependencies around it, I'm good to go with where I'm at. But just to show you what that would look like, so let's go ahead and run it and see what we get. So I actually have a status check running here that validates the steady state of my shop, which is essentially just the load balancer. That's running okay, because I want to, if I don't have a steady state, I don't really want to run anything, right? So that's kicked off, configuration saved, and it's running, looking good. And I have a place to place notes and observations if I'd like. So let's run through that same user experience. So I'm able to add something to cart. And now when I place an order, I can already tell there's some slowdown here. So that's not awesome. And truly, if I'm a e-commerce customer, I'm probably kicking on this like 14 or 15 more times, thinking that I broke something. And as you'll see here in a second, this will show a pretty nasty looking 500 error. So it's not a super awesome, there it is, not a super awesome experience there. So that doesn't necessarily match my hypothesis. So I probably want to go back in and actually halt this particular attack here, because now I want to actually dig in a little deeper and see where I went wrong. But also there's another half of this as well. Let's just validate that I recover. And I do, so that's good. All right, so there we go. Awesome, okay, cool. So making sure that we're back to it. So let's bring everything all together. So what is chaos engineering? Experimenting with failure. Why should we be doing chaos engineering? Because failures are inherent. When should we be applying chaos engineering? Early and often. Where should we be doing chaos engineering? Everywhere. Who should be doing chaos engineering? Everyone. And how? Well, that's where Gremlin comes in. So a few final notes. We actually have a very large chaos engineering community, Slack community of I think it's somewhere over 6,000 different engineers all talking and learning from each other. So come on in and say hello. There's also a free version of Gremlin that lets you do CPU shutdown and black hole attacks. Black hole attack is the one I utilized today. So go to that website, gremlin.com/free, and sign up. So thanks again for joining. We have a good bit of time to hop into some Q&A. So fire away from there. What I will say before we get into that, just an itty bitty plug, because I'm not done talking just yet. I really believe that by doing chaos engineering, we can make on-call, frankly, suck a little less. And something that's really cool is DevOps.com agrees with me. And so I will be speaking at DevOps Experience next week at 4 o'clock, I think, Eastern time. So sign up for that and check that out.
Yeah, you can always go to devops.com to sign up for that. Shameless plug on my side too. So yay. All right, great. So thanks so much, Jacob. We have plenty of time for questions. So if you do have a question for Jacob, go ahead and use your GoToWebinar control panel and get it on in. We've gotten some great ones in so far. So let's go ahead and dive right on in. First of all, Terrence says, cool hat, Jacob. So
thank you.
Props for the hat. Okay, so let's see. Here's one. How often should fire drills be performed, and what level should it be replicated in, like, real world?
Good question. So there's kind of two pieces to this that I mentioned on that slide. One is when you're onboarding a new engineer. I think that at least one every time you onboard a new engineer is a great way to start, because, and to put it simply, let's just make sure that if there's an alert that should be paging someone, that it does. Great way to test your phone. So good example of this for me is when I went on call for the first time at Fanatics. We had just signed up for PagerDuty. I got plugged into the schedule, and I went to bed one night and woke up to, why didn't you answer? Da, 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 da. And that's because it wasn't set up correctly. It was set up with the wrong phone number. So, and it sounds so silly, but like, how preventable was that, right? And then from an actual, if frankly, the good news is that the thing that I got alerted on wasn't a super big deal, but imagine if it was, whew. So yeah, that's a good example. And I think really a good place to start is to start monthly. So if you're not onboarding someone brand new, think about a monthly cadence, whether that's a full-on game day or just a chaos hour. Another good really good example is the person that's on call, give them the ability to do a chaos experiment as part of their on-call cycle, versus having to wait for something to happen and get paged. It's a good idea.
All right, great. Next question here. Does Gremlin run as a sidecar to your main container?
Good question. So not when you install it. So the way that it works is when you install it, it creates the Gremlin container that is running, and then that's what surfaces to the UI. Then when you implement a failure, whether that's CPU latency, that's when it will spin up a sidecar container that implements the failure, and then once that's gone, the sidecar is gone.
Nice. All right, great. As I said before, lots of time for questions, so go ahead and use your GoToWebinar control panel and get them on in. Here's a question for you. Let's see, hold on. I got two of the same. So where should I get started with chaos engineering?
So there's typically two ways that I like to start. So typically a common misconception is why I talk about production a lot is that you have to start in production and it's the only way you're going to get value, and that's just not true. Typically, I like to start in an environment that has a bit of monitoring. So typically with a lot of companies, that's their environment underneath production, which is typically called staging or QA. And then that way I can get immediate pieces of value right away. However, I talk a little bit about architecting for failure early. So there's also that piece around if you're a developer and, in a lot of cases, you're creating retry logic and timeouts in your application without any context of what will happen in the real world. So why not run those types of experiments way, way earlier, find out and kind of tune those pieces before you even get into a place where, your QA team is doing unit and unit testing, for example. So, and then what's cool is that these two things tend to kind of run in the middle and then eventually get you all the way up and through into production. Not even talking about your CI/CD pipeline. And that's another good example.
All right, great. Here's another question for you. How do you convince an organization that chaos engineering experiments won't take down our live systems?
Great question. So that's why you don't start in production right away. It's a confidence piece. So you're not taking down your live systems. That's not what you're trying to accomplish anyway. You're validating what you know or an assumption about your system and then proving it. So a good example, and this is why the blast radius is so important. You're not blowing up an entire data center, right? From or saying it's unavailable. You're simply saying, hey, if I lose a particular host out of these 5, my applications should still be running, right? 1, 2, I should get an alert or my monitoring should be able to tell me that, right? Mm-hmm. Then based off of that, now what about 2? What about 3? If I lose, then let's start talking about what happens when I lose the data center. Does that make sense?
Makes sense to me. Yeah. All right. Great. Let's see. Can Gremlin also black hole Kubernetes API servers?
Yes, it's one of my favorite experiments to do, especially with Kubernetes has a lot of pieces. So for example, an example that I used more of the container piece, but the tab to the right has all the lists of Kubernetes pieces that I could fail. So for example, if it's, let's say, a managed Kubernetes cluster, for example, let's say it's Amazon EKS, I don't necessarily have, I don't have a surfaced control plane, right? I know it's running because my cluster is running, but if I have that endpoint, so remember I mentioned plugging in that host name and port. That's where I plug that in. And so what happens when I can't reach that control plane, for example? It's a really cool experiment to do. Especially if workers can't reach the master.
Great. We've gotten just a ton of questions and they're really, really good ones. So awesome. Let's
fire away. Let's go
forward. All right. So once chaos engineering creates a failure, what happens next?
Ooh. All right. So let's actually unpack that a little bit. So it's not that chaos engineering is creating a failure. You're creating a hypothesis and then validating that. So then what's next? Either A, you validated that something that you were correct and you're resilient to a particular failure mode. Now automate that piece, because as we all know, things change and we're adding things and new features, and bake that piece into your CI/CD pipeline and validate that you're still resilient to that, a week later, 2 weeks later, a month later. But if your hypothesis was wrong, go fix it.
Nice. All right. Next question is it a good idea to have CPU and memory spikes tested in development environments and the infrastructure in production like environments?
I think it's less important because of the fact that you don't have that overhead early on. But I think it's still valid. I think it's still valid though. Because one of the things that's really interesting, I think, is we all know, whether that's CPU, disk, memory, everyone's aware of resource exhaustion as a common thing that can happen. And yet we still see companies running into issues with these. A company as resilient as anything can still, miss, and a log rotate and fill up a volume. So I think it's, from a prioritization perspective, it's probably not what I start with in a lower environment, but it's absolutely something I'd be thinking about.
All right, great. Next question, how is it best to start with something like a chaos tool if you're not sure about your application architecture or weak spots?
Great question. So with Gremlin, we actually have something called recommended scenarios that are based off of real world outages. So this actually started, so we launched this last year, and something that's really, really, really fun is it started with six really common real world outages. It's somewhere around 18 now, just based off of what we've learned, incidents that we've run. A lot of the scenarios that are in there are based off of experiences that we've had. I talked a little bit about, or I mentioned just at a high level, of the S3 US East 1 outage. I actually remember, I think it was like November 2017. I remember that day really, really well, because of the fact that literally the week before we had talked about going multi-region, and if we had done that, we would have been resilient to that particular failure mode. We chose not to, due to cost. We went down. So that's something that I don't think we as an industry really talk about, is the ramifications and how that's affected people's day-to-day. We know that the outage happened and it broke half the internet, it seemed like, but how did that affect you? And then, so those are the scenarios that I start to think about, and then that's where things really get plugged. I think folks get really get focused in on. And a good example, actually, complete sidebar here. We actually had an e-commerce company, and this VP of infrastructure was coming in and actually decided to run a game day, and as you can imagine, that really happens. This is a very engineer-heavy practice that typically is, at the engineer level, and then you have to get buy-in at the VP level to, get you to buy a tool and get you to invest time in. But the pain point in this situation was, why are my engineers getting woken up all the time? And now during the day, everyone's looking like zombies and nothing's getting done. So it became such a big pain point that the business needed to invest in this. And so that's another piece of it that's important.
All right. Okay, let's see. Next question. For a typical web application backed by APIs, hosted entirely on AWS, uses an RDBMS, are there any sample checklists that give us a jump start on where we can get started? What are the most common failure points we can test for? Or is Gremlin the tool that can get us started?
Well,
nice setup there, huh?
Yeah. Softball me, why don't you? No, in all seriousness, that's actually why we launched recommended scenarios, is for specifically to answer the question that you just asked. So because we talked a little bit about the different failure modes, and there's like 11 different attacks, but it doesn't really tell you where to get started or why it's important. So that's when we started thinking about unavailable dependencies. Actually, why don't I just show you really fast? So let me switch back to the UI here. Where are you, Firefox? There we go. Cool. So yeah, so recommended scenarios here. And then, yeah, like I said, it's gotten a lot longer. See, but in this situation, it's pretty common around auto scaling is a great place to start in the cloud. This is something that is very popular. It's one of the reasons why people fell in love with the cloud to begin with, just the ability to do these types of horizontal, auto scaling. But then folks are realizing that it's really hard to do correctly and really difficult to be ready for, because it's a bit unpredictable. Even if you set up, it should, go when we hit 80% utilization after 5 minutes, it should give me a new node. But again, that's an assumption we're making. Let's prove it. And then tie into, network latency, especially since you're in the cloud and latency is not always predictable. What's that network fallacy? Latency is zero, which we all know is
Right.
never true. And I touched on losing hosts earlier. That's another great one. And then we talked a little earlier about dependencies and region evacuation. So essentially 1, 2, 3, 4, 5 to get started.
Awesome. Awesome. All right. Great. So just a quick time check. We are 15 minutes to the top of the hour. I think we have time for, gosh, at least maybe 4 or 5 more questions. So let's just keep right on rolling if you're good with it, Jacob.
I'm good.
All right. Some of what you discussed seem like good negative testing practices. What do you see as a difference between negative testing and chaos engineering?
So there's a lot of different pieces, but I think the difference is we're using the scientific method. Like we're coming up with a hypothesis and of what we expect to happen, and then we're testing it.
Mm-hmm.
So I think it's a little more zoomed out. I think in my opinion, negative testing is very much about the failure and not about what happens around that. Like because I think this something that's really cool about chaos engineering is we're not just talking about systems failing or systems reliability. We're talking about people as well, and that's something that I'm really passionate about. Especially since we as an industry there's just an expectation that these 4 a.m. wake up calls are okay, and
Mm-hmm.
there's a health piece to this as well that I think is really important. But I think that's really a large piece of it. Someone was asking me recently, like what makes this different than any other testing. Like this is just another piece to it, right? There's we do our load testing, we do our unit tests, and then this is another piece of it. But load and unit tests don't ever talk about people, right? And so I think that's the major difference.
All right, great. Let's see, does Gremlin support AWS Lambda functions and or API gateway testing? In other words, how does it support serverless testing?
Yep, good question. So today, a lot of what I showed was on the infrastructure side, and I kind of talked a little bit about application level fault injection. So we actually support this for Java applications today. And also on our roadmap, a little more longer term, we're talking about Node and Python. So the answer is yes, comma, but. But yeah, so Lambda functions from a Java perspective, especially. So yeah.
All right, great. How do you use Gremlin to validate the resiliency and reliability of application and infrastructure?
So I'll love a little follow up there because I think that's kind of the overarching piece of this is just that. So just I'll roll back on the hypothesis piece I mentioned, whether that's wherever it is, infrastructure, application, verifying, monitoring, incident response, we're validating assumptions that we have, and then we're proving whether that's right or wrong, and then deciding how we move forward from there. So I think that's kind of the main piece. And I'm not wearing the shirt right now, but on our Gremlin shirts, on the back of it says "Break things on purpose." And so as fun as that is to say, and as true as it is, like it's a great logo type eye catcher. But the truth is we're really being thoughtful about, frankly, the pieces that we're breaking, because they're going to break on their own.
Right. Break all the things, right?
Exactly.
So, all right. Okay, next question. When application architects, design business systems, they assume that the system is always available and working. Typically, nobody designs for failures. So how do we bridge the gap between what chaos engineering finds? Should business workflows, how do we bridge the gap? Should business workflows change? Hold on, or system availability guarantee established?
So a lot of pieces to that. So
Yeah.
But I think the overarching question is should things change? And the answer is,
Right.
I think almost always yes, whether we like it or not. Change is
Mhm.
just a part of life, right? But I think you're spot on. The world of creating and designing systems, assuming that they'll never fail, is just a fallacy that I think we can't afford anymore. Especially with the fact that the internet and customers demand almost instant gratification. So I think truthfully, we need to flip that on its head. We need to assume that things will fail and then architect for that, even at that early design phase.
That makes a lot of sense. Okay. All righty. After the unpredictable chaos, how would auto analysis be carried out?
So this is a good question. A lot of the AI and machine learning piece, is an interesting one. I still tie it back to people. I think there's definitely a world that's definitely happening around auto analysis, but I think it's frankly a bit of a misnomer. I think that we're still relying on what's up here in a lot of cases, because we talk a lot about runbook degradation and that sometimes people are single points of failure, right? Just from a lack of knowledge transfer. So that's really, I think, way more important. We need to resolve that first before frankly we even talk about automatic analysis. However, that being said, I think that there's a strategy in mind for this. A good example, I talked a little bit about retry and timeout logic, right? Imagine a world where, because right now in a lot of cases that's very guesswork, and then something fails or something doesn't fall back, and then we have to tweak. Imagine a world where we create that, we inject failure, and then we say we recommend, but this auto analysis piece, I mean, we recommend you change this to this setting based off of the information that we have and the traffic that we expect. So I think that's where we're eventually going to go. I just don't think we're there yet, to be honest with you. We don't.
All right. Okay. All right. We have, I think, time for maybe one or two more questions here. How does Gremlin work? I like this question. How does Gremlin work with systems that are completely managed?
So depends on what you mean by that. So I'm going to assume you're talking about something like maybe like Heroku, where you don't have it's a full pass. I spin up my code and I deploy it, and then that kind of thing. So to be frank, not a way forward there. But like a lot of our customers have very mixed and hybrid environments. So for example, we talked a little bit about AWS earlier. So let's say we're running on this application is running on an EC2 instance, and it's talking to RDS, right? A managed database service, right? I can't install Gremlin on RDS. I don't have access to that. I don't even know where it is really, right? I know what the endpoint is, and I know the port that's listening on, and that's what we plug into Gremlin from that perspective.
Okay, let's go ahead and do one more question, then we'll close it on out.
Sure.
Does the Gremlin tool assume I am a complete noob and will walk me through the basic setup, how to choose items to test with description and how to understand output, etc.?
I am so glad that you asked this question, because this is something that I have been working on for a little bit. Something I didn't show earlier was what happens when you log into Gremlin for the first time. The first thing that happens is this, and shows you a bit of a 2-minute overview, and then we ask you a few questions about your systems to give you some places to start. And then once you update that, that's when we start talking about the failure modes that we would like to recommend you start with. So, oh, you're running on ECS? Okay, cool. You haven't done that yet. So let's start talking about that. Container orchestration, these are the experiments that we want to start with. Now, this says Kubernetes in this case, but just to give you an example of the things that we're working on. Also, as an aside to that, we actually have a customer success management team that will help you throughout that entire process as well. And a lot of the work that I do for proofs of concepts are around that hand holding. So all that being said, we can make that happen. Don't worry.
That's awesome. That's awesome. Okay, so we're about 5 minutes to the top of the hour, so I'm going to go ahead and close out the question and answer period. We had so many great questions. I think we got to most of them, but I know there were a couple that we unfortunately were not able to get to. So if we didn't, please know that that Jacob and his team will be getting a copy of all of the questions that came in. So I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar a little bit later on, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can go look for it there as well. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, so at the top of the hour, I did say that we would be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and do that now.
And while you're doing that, a quick note, in case you're impatient and you need an answer right now, my Twitter and email is right on the screen. So don't feel like you have
that's awesome. Yeah. So thank you. Okay, our first winner today is, let's see, Judy K. Congratulations, Judy.
Yay.
Our second winner. Yay, Judy. Second winner is, excuse me.
Drum roll.
Ritu R. Congratulations, Ritu. Congratulations. Yay. Our next winner today is Tom C. Congratulations, Tom. Yay. And then our last winner today is Ra I. Congratulations, Ra. And we'll be following up with all 4 of you offline via email to get your Amazon gift card over to you. So please check your inbox. If you don't see it there, please check your spam folder. Jacob, thanks for such a great webinar today. Lots and lots of great information. And I especially love those demos. They're so much fun to watch. So thank you very much for kind of, crystallizing what I think a lot of people had questions about. So, awesome. And judging from the number of questions that we got from the audience, just they got a lot out of it too. So thanks again. I appreciate it. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.
Indeed.